Hey, Geo students, welcome to day 2. Today we're looking at the distance formula, which is how we can calculate the distance between any 2 points on a coordinate plane. And to look at this, let's start it with an example. It says find the distance between the points -1, 1 and 3, 4. So again, I'm going to go ahead and plot those 2 points, and let's take a look at it and see what we see. -1, 1 is right here. 3, 4, so 1, 2, 3, 1, 2, 3, 4. So here we have -1, 1, and 3, 4. And again, I want to find the distance of this line. Okay, so the way that we can easily calculate this is we actually want to go back to something we learned just like the day before. We want to go back to something we learned early on in our geometry career. Now, finding the length of that line is difficult, but we can think of this anytime we're on a coordinate plane. It's really easy to make right angles and think about this in that form. So what I'm going to do is I'm actually going to turn this line into a right triangle. So watch what I'm going to do here. I'll use a different color to kind of highlight. I know I have this. It's really easy to calculate the length of lines when we're looking at them on horizontal lines or vertical lines on a coordinate plane, because we can just count the number of spaces. Right? When I count this number of spaces here on the bottom, I see that this goes a distance of 1, 2, 3, 4. And I see that I go a distance up 1, 2, 3. Now, I know it's been a little while since we looked at the Pythagorean Theorem, but how much time should it take you to calculate the length of the hypotenuse there? Right? The blue line, the one we're trying to find the length of, is the hypotenuse of this right triangle. Now you might say, okay, 3 squared, that's 9. 4 squared, that's 16. 9 plus 16 is 25. The square root of 25 is 5. But hopefully you saw, oh, that's a 3, 4, 5 triangle. I know those super well. So my distance here is a length of 5. Okay? So coordinate planes make it really easy because we can always change it into a Pythagorean theorem problem. My question is, how can we still use this Pythagorean theorem, right, without having to draw the picture or count the spaces? Okay, so let's talk about that real quick. I want to show you how you can get that 4 and that 3 in a little bit easier of a form. Okay, this 4 right here comes from the distance, right? It's the difference between the x's. So I can get that by subtracting my x's, right? I can do 3 minus -1. I know when I do 3 minus, when I subtract the negative, I'm really adding. That's how I can get that 4, right? I can get this 3 by, again, taking the difference in y's. 4 minus 1. That gives me a difference of 3. Well, what if I subtracted in the other order? What if instead of doing 4 minus 1, what if I did 1 minus 4? Well, 1 minus 4 would give me an answer of -3. Right? If I did the other one in the different order, -1 minus 3, I'd get -4. What happens, though, is because we're always squaring the 2 legs, right? Think about -3 squared. Well, that still equals 9. -4 squared, that still equals 16. And 9 plus 16 still equals 25. And the square root of 25 is still 5. So we're going to use the property that when we have a negative number and we square it, we end up with a positive number to help us so we don't have to worry about which order we subtract here. Okay, so The general distance formula is going to look like this. Again, we know this Pythagorean theorem. This is a leg. This is a leg. This is the hypotenuse. Okay. So what I want to think about is if I just, instead of finding the hypotenuse squared, I just wanted C, right? How would I get rid of that? Well, I do the square root on both sides. Again, how am I going to come up with this A and this B? Well, I'm going to get them by subtracting the x's. Squaring them, summing them, because that's the Pythagorean theorem, and that's going to give me my hypotenuse. So here's our general formula written for the distance formula with a d. We're going to say d equals the square root of x2 minus x1 squared, right? x2 minus x1 is like my a. I'm squaring it because you have to do that in the Pythagorean theorem, plus y2 minus y1. And notice I'm doing the square root of that whole sum there. The sum of x2 minus x1 squared and y2 minus y1 squared. So this is my distance formula. And again, that's kind of a nasty looking formula. But if you just think about it in terms of the Pythagorean theorem, it doesn't seem so bad. Okay, let's do a couple of examples on this to see how we can solve these problems. Okay, so here's example 1. Oops, hold on, let me make this a -4. Okay, so again, what I want to do here is I have these points. I'm going to go ahead and right now label them x1, y1, and x2, y2. It doesn't matter which one you call x1, y1, and which one you call x2, y2. I usually make the first one x1, y1, and the second point x2, y2. And now to find my distance, here's what I'm going to do. I'm going to say distance equals the square root of, I have to do x2 minus x1. So that's going to look like 8 minus 2. Make sure that's in parentheses and make sure it's square. Okay, because that's my distance formula. Plus, now I want to subtract y2 minus y1. Well, that's going to be -4 minus 4. Now, I'm going to be careful and not to try and do too much all at the same time. Okay? I got to remember I'm still doing a square root. So as I simplify the inside of this square root, I want to remember that this is still under the square root, and I'm going to do the square root operation as the very last step. A lot of times students forget about the square root, and then they get an answer that's wrong because of that. Okay, so I'm going to do 8 minus 2. I know that's 6. So I'm going to write 6 squared. Plus -4 minus 4 is -8. Okay. Now I know that 6 squared is 36. Again, I'm not going to forget my big square root, so I'm going to have 36 plus Here's where you need to be careful, especially if you're using a calculator, right? If you just type -8 and then the squared into your calculator, it's going to tell you -64. But you know that -8 squared is +64, right? If you're going to type it in your calculator, make sure it's in parentheses. -8 times -8 is most definitely +64. Again, notice it's still under the square root. 36 plus 64 is 100, so my answer is going to be the square root of 100. I know that the square root of 100 is 10. And that's my final answer. Okay? Let's take a look at another example. Okay, so here's the problem. Find the distance between -4, 1 and 1, -3. So again, I'll write my x1, my y1, my x2, and my y2. And I'm going to say my distance equals big square root x2 minus x1 squared. So that's 1 minus -4 squared. Don't just write 1 minus 4 squared. It's 1 minus -4, right? You have to be very careful in particular here as you're doing. Plus y2 minus y1. So that's -3 minus 1 squared. Now 1 minus -4, that's 1. I know that that means 1 plus 4. 1 plus 4 is 5. So I'm going to say square root of 5 squared. Plus -3 minus 1 is -4. Okay. I know 5 squared is 25. And I know -4 squared, again, is +16. I know 25 plus 16 equals 41. Now, I know 41 isn't a perfect square. I also want to check to see if it reduces, right? And I see that it doesn't because the 41 is a prime number. So my final answer is root 41. Let's say I solved the distance problem and I got a distance equal to root 75. Okay, this one would break down. I know it breaks into 3 and 25, and 5 and 5. Remember, the one I circle goes out front. Whatever's left goes on the inside. And so if you come across problems like that, make sure you simplify the square root. And that is it. That's the distance formula. It's really just a rewriting of the Pythagorean theorem with notation specific to the coordinate plane. And it's a very important formula to have down correctly. And it's important that you do your addition and subtraction and your squaring all correct. Okay? You just got to be very careful and make sure you do these things correctly step by step, and it'll be very easy for you. All right, that's it for today. Have a great day. Bye.